So, various species can uncertainty is not data and selected percent attributes and studied such maps on the entities and gave certain space of complete function at infinity is a selective isometry. Theory was extended by M to the case of vector value continuous functions. We find other studies of this type on other function spaces. For example, on function algebras and certain algebras of holomorphic functions, we have a study due to Atori, Miura, Oka, and Takagi. And for the space of functions of bounded variation, we have a study of Hosseini. We want to local isometries on pointed Lichy spaces. Recall that a map between two metric spaces is Lichy if there exists a constant C such that the distance from Fx to Fp is less than or equal to the constant C times the distance between X and P. Then the supremum of these versions is the Lichy constant of F. The Lichy space lip of S is the subset of bounded Lichy functions from the metric space X into the field of real or complex number with with one of these two norms. These are the classical norms of the space lip of S, the maximum norm and the sum norm. Lip of S is a Banach space with this norm. The Lichy constant is a semi-norm, but it is not a norm. For this reason, here the uniform norm. Another option is to consider pointed metric spaces. A pointed metric space is a metric space with a distinguished element is at S, called base point. This Lichy space is the set of all Lichy functions from the pointed metric space to the field vanishing at the base. Now, the Lichy constant is a norm on the pointed Lichy space. And the pointed Lichy space is a Banach space with this norm. In a previous work, we studied two local isometries on the space lip of S. Assuming the group of lip of S is canonical and the metric space X is bounded and separable, we obtain that every local isometry of lip of S is a surjective linear isometry. Later, more studies about this subject appears. For example, one study of Jimenez, Lee, Peralta, Wong and Wong, other study about the four last authors. More recently, OI published a paper about local isometries on certain subspaces of functions, including Lichy space. Particular problem is the following. Is every two local isometry between pointed Lichy space linear and projective? To solve this problem, the first step is to obtain a representation of two local isometry. To get it, we of Fiori and Mornar and Cabello Sanchez. Fiori used the Banach-Stone theorem. We need something like this on pointed. We find two authors describe surjective linear isometries on pointed Lichy spaces. The first one is Meyerwald. He describes surjective isometries on pointed Lichy spaces considering Helder metric spaces. The second one is Weber. He extended Meyerwald's result in his two books about Lichy algebras. Weber uses uniformly concave metric spaces. A metric space is concave if the triangular inequality is strict at three different points, x, y, and z. And a metric space is uniformly concave if such a strict triangular inequality is controlled by a delta. When the third point z is outside some balls with centers x and y and radius prefix epsilon. First, examples of uniformly concave metric space in his book. Concretely, Helder metric spaces are uniformly concave metric spaces. For this reason, Weber's result extended Meyerwald's result. The description of surjective linear isometries given by Weber is the following. The surjective linear isometry T is a weighted composition operator plus some functional. In the weighted composition operator, map phi is an A dilation. That is, it verifies this equality. Phi is close to being an isometry between the metric space Y and S. Another important tool to obtain our representation of two local isometries is picking functions. We used these picking functions from Weaver's book. With these picking functions, we can determine 2 prefix point x and p, because we have this equality and this inequality. This is an example of the function g sub xp. The other function h is a translation of the function g. Really, we must call the paper because the field of real numbers is not a concave uniformly concave metric space, but only holding we have a correct example. This is an idea of the function. We need other picking functions. For example, this function G3 have more properties than the previous function. We have the previous property and 3 additional properties that allows us to combine our function G3 with others previous functions from previous works. This is an example of the function G3. This is our representation of two local isometries. The difference or increment on delta F is equal to the increment on the composition of phi with the function f times certain scalar. Here, phi is an A dilation. Unfortunately, we have this description only on a subset y sub 0 of y, not on y. But y sub 0 is isometric to y. And the previous theorem can be reformulated as follows. We can describe the two local isometry as a weighted composition operator plus a homogeneous Lipschitz function, mu. Finally, we have a lemma to obtain our main result. Here we have 3 points, x1, x2, and x3 in an appropriate situation. The distance from x1 to x2 is equal to the distance from x1 to x3. We have 3 balls in this form, and outside the balls, we have a subset of point Rn. Then we can obtain two functions with this form. In order can determine the points x1, x2, and x with the function f and g, and the same for the points Rn in the countable subset points Rn. When we assume that the space X is a countable subset, points Rn is dense proposed. And with this lemma, we obtain our main theorem. We can prove that the subset y sub 0 is equal to the metric space y, and then the local isometry is a projective linear isometry between the pointed Ricci space. These are the references. And that's all. Grazie mille.
Thank you, Mrs. for your talk. Time to questions or remarks. Okay. Oh.
And what will be the next step?
Well, about two local isometries, I don't know. We are studying another other type of question in other spaces. But I don't know what happens with to local isometries for us.
Thank you. Question or remarks? Well, if there are not more questions or remarks, thanks again, Moises. And this, okay. And this session is officially closed. Up to tomorrow. Thank you to everybody. It's officially closed. With all the meaning of that.